Okay, students. Here, today we just will be understand the sum of the terms regarding the mirror, and then we go ahead. Let's start with the first one. If I take example, for example, we just will consider the concave mirror. So, bachcho, can we say that it is the concave mirror? Yes or no? Then definitely no. Why? Until and unless we are not going to be show the plated, we are not going to be consider it as a concave or convex. Here, I hope it's a straight line. Fine. So here we just be consider this is called as the P for pole. P for pole. This line is known as the principal axis. This line is known as the principal axis. Here, suppose parallel light incident on the surface. It's going to be like this. Like this. Parallel light incident on the surface, then this light will reflect and it meet on a particular point on the principal axis where all light rays are converged and meet the point on the principal axis. It called as principal focus. It called as the principal focus. Here, one more thing, very interesting. These rays are known as para-axial rays. Why? Then these rays are parallel to the surface. Parallel to the surface. That's why it called as the para-axial rays. So again, repeat. First of all, this is concave mirror. The midpoint of the concave mirror is called as the pole. The line passing through the pole is called as the principal axis. The rays which are parallel to the principal axis is called as the para-axial rays. When all para-axial rays incident on the surface, they all will converge and meet the point on the principal axis. This point is called as the principal focus. So it's very interesting. The distance between the principal focus and pole is known as the f. Small f, it is known as the focal length. It is known as what? Focal length. So let's start with the terms. First of all, pole. Then very simple, midpoint of any mirror is called as pole. It's a very simplified and very simple sentence. Next, principal axis, line pass through the midpoint of mirror is called as principal axis. Got it? Doubt? Fine. The next, we just maybe understand the term para-axial rays. So the rays which are parallel to the surface, parallel to the principal axis is called as para-axial rays. See, a wonderful word. Para-axial means parallel plus axis, so parallel to the principal axis. The next one is principal focus. When all rays are incident on the surface, they will converge and meet on particular point at principal axis. So all rays are incident on the surface, they will converge and meet on the particular point at principal axis is called principal focus. Next, focal length. The distance between pole and principal axis is called as focal length. It's going to be denoted by small f. Fine. See, here one more thing that we have to keep in mind. It's called F and it's called the C. It's called R. Here C is known as the center of curvature. Now what do you mean by the center of curvature? Center of curvature, it is center of spherical cell from which mirror is made. Simply we can say that suppose it is this center and we just going to be form this mirror like this by cut down it. That's why this is called as the center of curvature. Definitely we know that in spherical cell from the center to this distance is going to be considered as the R. So this R is known as radius of curvature. Radius of curvature. So radius of curvature It is distance between center of curvature to pole is called radius of curvature. It's going to be denoted by R. This is called pole. One more very interesting thing and very important. Always keep in your mind that this principal focus, small f, so R is equal to 2f. It is relation between radius of curvature and focal length. That's it. Okay. Now, next part. Here, if we use any object like this, so this is called as the object. Rays is going to be like this, and it will become like this. So here we just will consider it going to be form the image at here. It's called the image. So this object distance from the pole is given by u, and the distance between the image and pole is given by v. So guys, keep in your mind, u is distance of object from pole and v is distance of image from pole. F is focal length. Here this height, it is known as the HO. So HO is known as height of object. HI is known as, this is called as the HI, height of image. And the relation between u, v and f is given as below. So 1 upon f is equal to 1 upon u plus 1 upon v. This is called as the mirror equation. It is called as the mirror equation. Very useful equation to solve the numericals. So this all part is given in a mirror. Got it? Fine.